So today our topic of discussion is basically metallic bonding. So what actually is metallic bonding? It is it is an electrostatic electrostatic force of attraction between cations and delocalized electrons. So how does metallic bonding occurs? First of all, we know that metal, they always tends to lose electrons. Okay, so metal always tends to lose electrons, and we know that non-metals on the other hand accept electrons. How metal lose electrons? Why we are saying that metal lose electrons? Let's discuss about sodium 1123. Okay, this is 11. So its electronic configuration is basically 2, 8, and 1. So now it has to complete its outermost shell. So what it tends to do, it will tends to lose electron, and it would become a cation with the loss of electron. So its electronic configuration would become 2, 8. So in this way, we have seen this thing that metal in fact lose electron. Because of that, it would become a cation. So in metallic bonding, what happens when metal loses electron, they become cation, and those electrons will move around them. Okay, and will move around them, will be freely moving around them, like you can see in this uh, picture that there are basically cations. This is basically the structure of metallic bonding. So what happens? These are cations. How these cations are basically formed by losing electron. They are formed by losing electron. So what happens? These electrons that are basically removed from an atom, they would be moving around, you can say these cations, okay? And there is basically the force of attraction that has been developed between this electron and this cation. So because we know that electrons are negatively charged and these cations are positively charged, so this force of attraction that has been developed between cations and these sea of electron, they are basically known as electrostatic force of attraction. Electrostatic force of attraction. Okay. So now these electrons, they are called as basically delocalized electron. Why? Because they are freely moving. They are freely moving. That is why we are calling them as delocalized electron, because they are freely moving electrons. Okay, so now what happens that because of this electrostatic force of attraction that is present between electrons and these cations, because of these cations would remain in the fixed position. These cations would remain in fixed position while these electrons are always moving. Cations would remain in fixed position. Okay. On the other hand, the electrons are moving. So now let's discuss about the properties of matters. and let's discuss about the reasons of these properties as well. First of all, our first property is that metals have high melting point and boiling point. So what's the reason regarding that? Because of strong electrostatic force of attraction. I'm just writing EFA here. Electrostatic force of attraction between cations and delocalized electrons. And delocalized electrons. Now, next property is that they are good conductor of electricity. Good conductor of electricity. What is the reason regarding that good conductor of electricity? We can say because of free moving electrons. What is the reason regarding that? Because of free moving electrons. Okay, that is why they are good conductor of electricity, because of free moving electrons. Okay, so now let's discuss the third and the last property, which is that metals are basically malleable and ductile. So what we mean by malleable, malleable means that metals can be bent in any shape. Okay, metals can be bent. And what we mean by ductile, that they can be stretched in wires. Okay, you have seen the copper wires. So how the copper metal has been converted into wires, the reason is that because of their metallic property, which is ductile. They are ductile. They can be stretched into wires. So how does basically this happens? Because when a force is applied on the metal, like you can see when a force, let's take another color regarding that. Yes. So what happens, you can see when a force has been applied over there, okay, you can see that this layer would move in this direction. And what happens, these layers would slide past each other like this. They would slide past each other. Okay. This layer would slide past each other. So when a force is applied here, then this layer would move in the forward direction, which caused them to slide past each other. So what is the reason regarding that? That when a force is applied, when a force is applied, the layers would slide past each other. When a force is applied, the layers would slide past each other. Would slide past each other. Okay, so this is basically the reason for metals have which are malleable and ductile. So this is all about the topic of metallic bonding. Thank you so much for listening. Kindly like, subscribe, and share my YouTube channel. Thank you so much. Allah Hafiz.